everyone, welcome to the second session in the developer track. I think we can get started, most people will be here by now. So similarly as before, we have our red.skyline.be DataMiner that you can connect to test and follow along. Everyone has gotten a note, I believe. So if you log in with user and then replace the X's with the number that you got, you can log in with your specific user and then there will be an element for you there that you can play with. So the first session was more about all DIS features, and this second session will be more about creating a protocol from scratch, and more specifically a REST API that we will implement, or at least part of it. So what will be discussed or introduced in this session? First of all, we'll have a quick look at the API that we are going to implement. It will be a very small part of that API because we are going to implement part of the Amazon Web Services API, which is quite huge, of course.
Yeah, that's nice.
As a first part then of this training, it will just be about protocol building blocks, so everything you need to actually create a protocol, params, groups. Some of you will have already seen it in the previous session, but we'll go a bit more into detail. And then I'm going to start a new protocol and give a demo of the ListMetrics API call, which is the first one we're going to implement. So for these two parts here, you can just follow along with what I'm doing, but I suggest you don't try it for yourself yet, because I will use some snippets to generate code a bit faster and explain you how it works, so we can actually finish something in this session. And then if you want to, you can actually try out for yourself another API call to actually get a value. And then the last part, I will quickly show how you can debug the driver a bit further. All right, so let's start off with the API. We have actually an instance running on the Amazon Web Services API, or Amazon Web Services, and more specifically the Elastic Compute Cloud, where you can just launch applications and VMs. We have one or multiple instances there, and that was also displayed yesterday by Ben, I believe. So we will use the same thing here to actually get metrics for that instance. I'll show you in a minute then where you can find that on the Amazon site itself. So the actual API we use for that is the Amazon CloudWatch API. That's not just an API, you can also use dashboards inside Amazon with that to get certain metrics of, in our case, the compute cloud environment and instances, but it works for all Amazon Web Services, but we are just going to focus on the one we need.
Can you get that from just the API?
Yeah, you can get all API details on their site, and I'll show you in a minute. Note in this case for the CloudWatch API that this is priced, so it's not all free. Some parts are free, we will only discuss or see the free parts here, but depending on whatever you use from the API, you will have to pay at the end of the month. So it's not that straightforward that this amount needs to be paid for whatever you use for the API, but depending on how many requests you do, you will have to pay more. So how do you make an API request? And in our case, we will use post requests. So what is specific to them is that we will always use post requests, but as you can see, we don't specify an endpoint. Instead, you just need to specify the host you want to send a request to. So these are actually all the headers you need to provide in your post requests to actually make this work. That's also what we are going to do today. So some of them here are just your standard HTTP headers, and some are more specific to the Amazon Web Services API. Why do you need to specify the host here? Because in their case, you have a lot of different regions you can pull data from. And depending on what region you use, you need to specify or get other data. And then the target here is how you actually specify which metric or which API request you want to execute. And then you need an authorization header that we will need to build as well today to actually be authorized and get a response. So the first call that I'm going to show to you is the ListMetrics call. What this one actually does is for every instance we have in our compute cloud, we will get a list of the metrics that are available. This will then return, for instance A, for example, you can get CPU utilization, discrete. These are the API calls and the metrics that are available for you. And in our exercise, we will do this once after startup of our element. So then we will have all metrics that we can pull, and then with the second call, we will actually get the value for a certain metric. So what is specific then to this call is that here in our target, we specify ListMetrics, and the only thing we will provide in the body of our request is just the namespace, in this case EC2, which means that we want to retrieve data for the Elastic Cloud. And then the second one that you can follow along if you want to later on is the GetMetricData, and that actually gets the values then. So here we need to again update our target header to our new call, and we need to specify a little bit more in our body because they need to know, of course, which metric we actually want to retrieve. So we will have an object of type metric data queries that I will show you, where you specify the instance that you want to call and the actual metric for that instance. And we also need to specify a start time and an end time, because Amazon doesn't give you the real-time value all the time. It could be for CPU utilization that they only have a value every 5 minutes. So you need to specify the interval in which you want that value to be returned. So it could be that we can also choose to give me all values for the CPU utilization of the last hour, for example. Then you will not get one value, you will just get an array with a lot of different ones. And this is how our protocol should more or less look like at the end of this session. So we will just have one table with all our instances, the metrics we can poll, and then we will, for this session, not use timers or polling. We will just have one button where we can poll a single metric. So let me quickly show this on the Amazon website itself. So this is our console if we logged in. If I go to Elastic Compute Cloud, you can see here our dashboard, and I have one running instance in this case. If I select it, I can just see some more details about this VM. And if I go to the monitoring tab, these are actually all the metrics that are in the free tier of the CloudWatch API. So these are all the ones that I am also able to poll through their API. And here you can also see that it's only every 5 minutes that we have a new value, so we can only get them at that time as well. Then of course there's also more information about CloudWatch and how it's used, what the pricing is about it. So in this case you can see we're using the free tier and we can just get the basic monitoring metrics. If you're interested in more advanced ones, you can check how much it would actually cost you. And then regarding API requests, you can see here that everything of their API is available online. So here they describe in more detail how you need to do a post request, what attributes you need. And then here you have a list of all actions. And these are the two ones that we will use. So whatever I showed in my slides is also available in here. Okay. So now that we know how or what API we want to implement, let's first have a look at the protocol building blocks, because if you never worked with the protocol before, it will not be that straightforward to do this. So let's start off with just an overview of what we will need today, or what is the general blocks that you need in a protocol. You can divide them in more or less 3 sections. We have our protocol header. This one just identifies a name, a type, a version. Then you have the biggest block, which is everything we need for our logic. So we'll go deeper into all these blocks and explain what they do. And then the last part is communication settings, which is also something rather small, but it can be very useful for an operator if he creates his elements, that we actually define some of the settings already, that he doesn't need to think about it. All right, so let's jump right into the header. For those that already followed the previous session, you already know what this is. But this just displays everything we need to have a unique ID, a unique name for our protocol. So in our case, for this example, we will use Amazon AWS CloudWatch as a name. And the version here, I'm going to work in 0001. On the DMA, if you connect, for every user, I created a separate version, and it all starts with the first number of your user that you have on your paper. But we'll come back to that later on. The type of a protocol defines what polling you will use. In our case, this needs to be HTTP, because we are going to use HTTP requests. But this could also be SNMP or serial, for example. That just depends on the type of device or service you want to connect to. And then one side note about the integration ID and the vendor and device OID. These are items that you can get from Skyline. So if you create a protocol, you can register it with Skyline, and then Skyline will provide you with the values you need to use here. Of course, you don't need to wait until Skyline responds for that. You can just configure them then later on. Okay, so now let's have a look at the building blocks, the main ones for logic. First part here is just for polling. So for polling, we regularly do that via a timer, where we specify how fast and how frequently we want to poll certain things. And items in a timer will always be groups. So a group is like a to-do list or a block of items that you need to send towards the device. And once the device responds, we can update our parameters then. So let's first have a look at parameters. For probably a lot of you, this will be a recap if you already worked with protocols. No matter if it's a parameter or any other block, it always needs to have a unique ID, because this is used internally in your protocol to link things to one another, but this can also be used externally. For example, from an automation script, you want to retrieve a parameter from an element, you can do that via the ID. And then specific to a param, it also needs to have a unique name and description. One side note is if you have a write parameter, it will have the same name and description because that's how you link them to one another. The name is used internally in a protocol, and then the description is what you will see in your element cards in DataMiner Cube. And then there are mainly two different types of parameters. You have your displayed parameters that you all know in your elements, like you have here a total processor load or a table or a button. But we can also have internal parameters. For example, in this case for a polling buffer, if we want to retrieve things one at a time, or in the case of the protocol we will create today, we will need some parameters for header values or for the request body we need to send. So these will be internal parameters. Now with DIS, if you followed the previous session, we have seen that we have a lot of snippets available for parameters to make it easier. And you can even generate parameters from either the MIB browser or from a JSON or XML response even. But that's something I will show them later. So next up is groups. Again, it needs a unique ID like every other item. And it's like a to-do list. So in this case, for example, you can see the two groups that we will need for our protocol that we will create. And they both contain a session where we then define the post request we want to send. So with this group, we can then actually execute that request. But groups don't always or aren't always used for retrieving data. They can also execute logic internally, and that's also what we will need. And this is actually an example of that. This is a group that we would execute after starting up our elements. And this group will then just, instead of poll something, it will execute an internal action. So in this case, it actually executes a quick action, but I'll come back to that. One side note about groups is that they are always executed sequentially. So in a normal protocol, at least, you cannot have two groups executing at the same time. So only when the previous group is done, the next group can be executed. And then what is now maybe the most important part or the newest part, if you never worked with an HTTP driver, is a session. The session is where we define what we actually want to send and what we want to do with the response. So in the session itself, you just give it an ID and a name, and there are some extra attributes there where you can define credentials if you need to have some kind of authorization, or you can have proxy settings or configure what you want to do in case of a timeout. If you do specify a username and password, for example, and link that to some parameters, then DataMiner will automatically try the authorization for you. So by default, it will try basic authorization. If that fails, because of the headers that it gets back, it will know what to use. And actually, you don't need to play with all different headers you might need for your authorization. In our case, because we implement Amazon, we cannot use that, so we will have to build our own authorization header. And then, as you can see, in a session, we actually just have another block, which is a connection. And that connection will then contain some XML for our request and some XML for our response. In our case, what do we have in there? We have our HTTP method, which will be post, but this could also be a get or a delete or whatever other method you have. And you can specify the URL, the endpoint that you need. So you don't need to specify the full URL, it will always add it as an endpoint to the IP that you configured in your element. In this case, this would be static. You can also link that to a parameter. If it's a dynamic endpoint that you need to use, then you can also link that to a parameter. And then to add your standard HTTP headers, we have a header stack. These are all the headers that we will need for our Amazon implementation. You can see some of them linked to parameter ID. That's because they are dynamic. It depends on, in this case, the region that we defined in the IP that we set for our elements. And for our authorization header, for example, that's a string we need to build, and we actually need to use an access token and a secret token at Amazon to actually get authorized. So that's why these link to a parameter. The other ones are static, they never change, so those we can just hard code in our protocol. And then the last thing is the data, the body we actually want to send. In this case, we will use the data tag for that, and our bit parameter with ID 13 will actually contain the JSON we need to send. Then for our response, of course, we cannot configure that much because we don't know what we will retrieve. Instead, what you can do is define parameters where the status code will be set and the response will be set. So whenever we execute something or send a request, when the response comes back, the body of the response will be set in parameter 15 and the status code will be set in parameter 14. Then we can check the value of that parameter and figure out if our call actually worked and parse our response from there. A side note about headers in the response: if for some reason you need the value of a header that you got back, then you can also specify your headers in the response. Of course, not static, then they will also be linked to parameter ID, and that parameter will then also contain the value of that header. Okay, so the last part for polling is timers. Timers are used to at regular intervals poll certain things from either the device or some service. And when you use the protocol root snippet, then it will automatically add 3 timers already for you. In this case, a fast timer that will execute its contents every 10 seconds, a medium timer that will execute it every minute, and a slow timer that will do it every hour. Why do we do this? Because it could be that you have alarm data that you want to poll really fast, but you could also have configuration data that is not eager to change quickly, then you poll that slower. Note that there's no use of adding 10 or 20 timers with 5-second difference, because I already explained groups are executed sequentially, so they are actually added to a queue internally, and if you just have 5 seconds between all your timers, in the end, it won't matter that much. What is special about the timer here maybe is that this means when you have an element card open for this protocol, that it will poll twice as fast the data that is in this timer. So to define the speed of your timer, you do that in your time tag in milliseconds, so in this case 10 seconds. And the interval here, you can always leave it to the default value because that is the time it will take between groups. That's just to not overload the device. We really do it fast. Yeah, and that's all you need to know basically about timers. So now that we saw the items we need for polling, there are also some protocol blocks for eventing and triggering. So for example, when you change a parameter value in your protocol, we can trigger on that. So with a trigger, we can define what we want to trigger on, and then that trigger will execute a certain action. And in that action, you then specify what needs to happen in case that event occurs. And then, like you saw in the previous session, or if you already worked with protocols, if you have more advanced actions that you can't just configure in XML, we can have quick actions with C# code in there, and then you can do whatever you want, of course. So let's first have a look at triggers. There are a huge amount of combinations that you can have and that you can trigger on. For example, you can trigger or have a trigger after startup of your element. On parameter changes, on timeouts, before or after groups, there are all of them. So here you have some examples. In case parameter 222 changes, this trigger will go off. Here, after group 32 is executed, this trigger will go off. And here you can actually see that there is no indication when that trigger should be triggering. In that case, instead of triggering on an event, we will actually trigger that from a quick action. So if we're done with a quick action, we can actually decide we want to execute a group, for example, then we can use a call to execute that trigger and execute its contents. Something extra that we haven't seen yet is that you can add conditions on here. For example, for this trigger, if parameter 222 changes, we only want to execute the action here in case it changed to yes. The trigger will always go off, but it will only execute its contents if the condition matches. And as an example here, you can see that you can create all kinds of combinations you want. So from a trigger, you can execute an action. Actions, again, there are a lot of combinations, a lot of things you can do with them. In this case, executing a group or clearing a parameter. There are quite a few. If you want to know all of them, I suggest to check the protocol development library on GitHub and search if you find one that you need. Same as for triggers, we can also use conditions here. And only when the condition matches, it will actually do what it needs to do. Now, onto quick actions. A quick action also requires a unique ID, same as before. And a quick action only triggers on parameter changes. So that's different to triggers. There are not a lot of combinations you can use. Only when a parameter changes, the contents of the quick action will be executed. So even though this attribute is called triggers, these are actually parameter IDs, not trigger IDs. And then as you can see, we don't need to have one quick action per parameter change. We can combine multiple into there, and then just in the quick action check which one triggered it. So this is C#, and this is just for advanced logic in there. One side note that I also want to mention is that you can actually have a quick action of type precompile. As you can see, this is a special quick action. It doesn't have a trigger attribute. What this quick action does, and is different to the other ones, is that it will only contain code, for example namespaces or classes, that we want to reuse in other quick actions. If you have 3 different quick actions that more or less do the same thing, then the code that they share can be added to this quick action instead. And if you ever need to do a change, you only need to change it once rather than 3 times. How do you link this quick action to other ones is with DLL import here. So here you can see that we link quick action 1 in here. This is not clear now, we will use it in the exercise as well, and then it should become more clear. And here you can also see then, if you use other assemblies, that you can also reference them this way. Alright, so the last step or the last part of our protocol building blocks is the port settings. So this is used to provide default communication settings. In this case, what do we put in here for our protocol that we will create? We will set our IP port to 80 because it's an HTTP request that we will do. And the special one for HTTP is that we provide bypass proxy in the bus address. The bus address basically is a field in your element where you can pass values along to your protocol, or in this case configure extra details. The bypass proxy should at some point be an extra checkbox you have for an HTTP protocol, but until now you just need to define it like this. Why do we use this? Because for HTTP requests it could be there's a proxy in between that it caches the value, and instead of sending it towards the API, it will just return our cached value. And that's something we don't want, of course, because we want the latest value. So that's it for our protocol building blocks. So let's start actually creating, and let's hope that they make sense at some point. For the remainder of this session, I will mostly be seated because I need to switch a lot between Visual Studio and my slides. If I go too fast, just let me know, because it's quite a lot we have to cover. So to start a new protocol, what I will use is the Visual Studio template. Those of you that followed the previous session already saw this before, but not too long ago in DIS, we actually added a template for both protocols and automation scripts. And now it is actually possible to just create a new protocol from the Visual Studio menu. Before we didn't have that, but we had something similar, which is the protocol root snippet. So if you used that before, that's more or less the same. If you started from an empty XML file, you could use that snippet and you had the same thing. What the template does for you is actually already built part of a protocol. So in here you can see the result of using that template. And what is specific to that is that it already adds some items in there. So what does it add? It adds the after startup flow. So as soon as your element starts, this flow will be triggered, and that actually works with a trigger. I'll explain a little bit further then what the flow exactly is, because it's not as straightforward as you might think. Then it also adds the basic timers that I showed, the 10-second timer, the 1-minute timer, and the 1-hour timer. And it will also add a pre-compiled quick action already in there that you can use to add your custom code that you want to share. Of course, here there is no code in there because we have no idea what you want to share. And then the next thing we will do is define our header. As I explained already, we will use Amazon AWS CloudWatch as the name, and the user ID should be the one you start your version with. So if you check on the DMA, you will have a version for your user. So let me start with that already. So I have here an instance of Visual Studio running, and there's nothing there yet. So let me go to File, New, and select File. Here I have the DataMiner item. I select the protocol template in this case. And when I open it, you can see I already have a file with some of the building blocks in there. Let me quickly save this. I'll use 002 in this case because I already have 001 on the DMA. And the name is Amazon CloudWatch. Now, as I mentioned, the integration ID, the vendor OID, and device OID is something you can get from Skyline when you register your protocol. For now, we won't worry about that and won't use it. The only thing we do need to do is change the type to HTTP, because we will implement an HTTP API, so we need to make sure that the type is correct. Is this readable for everyone, or if it's not clear, let me know. Maybe I can make it a bit bigger. All right, so now we have defined our header. Let's move on. Next thing we will do right away is define our port settings. Why do we do that now? Because when we create our element and we change the port settings afterwards, this won't have effect anymore. This is only in effect when you create your element for the first time. So what we will define is what I showed already before. And then you can see that actually here, these things are already pre-configured. The user doesn't need to put them in there anymore. Especially for the bypass proxy, if you don't know about it, no one will know what to put in the bus address. So let me also do that. As I mentioned, to move along a bit quicker, I will use some snippets to speed up this session. Otherwise, I have a lot of typing to do and we will not get there in time. By the way, to access snippets, you can either right-click, use snippet, and then insert snippet, or you can use Ctrl-KX, which is the shortcut to do more or less the same. Of course, in your case, you won't have this folder. This is just there for me for this exercise. You will only have the DIS snippets there, and maybe some other ones if you created them before. Let me check if I'm actually connected to our DMA. All right, and now if I publish, I should have my protocol available there. look here, you can see that my new version is on here. So let's create a new element. You can see now, because of the port settings, that this is pre-configured and I don't need to do this anymore. Let me make sure this is at least correct. So here, I specify what region I want to pull things from. We will use this later on then to also build our request. Then let's just call it demo for now. Alright, so now we have a protocol. Of course, there's nothing in there yet, so let's continue with that. And let's start with the actual demo of adding the ListMetrics requests. We will need to do quite some steps, but I'll do it one by one. Again, I'll use some snippets to move along faster. Let me know if I go too fast or need to explain something in detail, because at some point I will add a lot of code in there, and I'll try to go over all of it. So first thing I will do is add some parameters. We will need some displayed parameters for our access key and secret key, and then we will need internal parameters. These are all used to build our headers, basically, and then also for our request and response. So let's start off with that. Let me start with the displayed parameters. So if I go to DIS snippets, you can see here in the param folder that there are quite a lot of snippets available. If I use displayed param, then I just need to configure them, hit enter to get out of the snippet configuration, and my parameter will be there. But again, I have one of my snippets available. Authentication params. So I have two params here, parameter 100 and 102, one for my access key and one for my secret key. Note that these are both saved. What this attribute does is save this value of that parameter in the database. So if you restart your element, the value will be loaded again. Otherwise, if you don't do this, every time your element, the DataMiner restarts, the user would have to configure his access key and secret key again. And to make it easier for myself, I also added a default value. In normal situation, you wouldn't do this, of course, for user keys and secret keys, but if I need to start typing this, I will probably make a lot of mistakes. And then here, you can see that I added an option password. This is because password parameters, we don't want to actually display the password directly in Cube, so we will use dots then instead. So now I have these two parameters, but if a user wants to configure this, he needs to be able to change that value. So to do that, I also need to add a write parameter. And with DIS, this is quite easy. I can select both my parameters, right-click, and choose Generate Write Parameters. Then I see all the parameters that I selected. You can see for our write parameter, I just added an offset of 1. If I change this to 100, for example, and update, you can see that it now uses an offset of 100. For the sake of this exercise, we'll just use 1. And I need to use the setter option. If I click OK, you can see that DIS automatically added the write parameters for me. And it has the setter is true option. That option basically just as soon as this write is set, will update the read parameter with a new value. Right, so let me quickly save this. So now we have our access key and secret key parameter, but we also need some internal parameters. So let me also add those. I seem to have another snippet for that. So now I added a bunch of internal parameters. What is the difference here? That they don't have a display tag anymore. These are not parameters we will add on some element card. The user should never see those. These are just internal to make sure our protocol actually works. The IP parameter is a special one. It's not of type read or dummy or whatever. It's actually of type IP. This parameter will, as soon as our element starts up, be filled in with the IP that was configured in your element. So in my case here, if I go to the cube and click edit, my IP parameter will automatically get this value as soon as my protocol or element starts up. Why do we do that? Because we need to retrieve the region from that to build our request. So let's go back to Visual Studio. All the other ones are just our params for, in this case, the date, the authorization header, and then the request and the response data. Okay, can everyone still follow until now? If not, let me know. Yeah?
Does it matter that you put trending false on one branch and not the others? Is that just
Well, for the other ones, it doesn't matter because they're not displayed. You can never trend displayed params.
Yeah.
For this one, we specify trending false because the default value is true. So if for display params. So in this case, if I don't add it here, this param would be available in my trend template. And I don't want it, so I disable it. Do note, although this is an internal param, I do have the display tag. That is just for debugging. If I want to know that my request actually works, I will display this and see that the response is actually coming back.
It's an SLM in rates.
Yeah. So now that we have our params, next step is to display them. So displaying parameters can be done with the display editor in DIS. So display editor is an editor where you can create pages and drag and drop parameters on there. You can even edit parameters further by using this icon, so let me show that as well. If I open the display editor here in the ribbon, then you can see, because I used the template, that there's already a general page on there. If I would want to create a new one, I can go here, click new page, add a name, and it will be added. For now, we only need a general page. I note that DIS also gives warnings. In this case, it says no parameters are displayed here. Why does it give this warning? Because that page will not be shown in Cube if there's nothing on there. So to add my parameters, I can select them by just holding Shift and drag and drop them on there. You can see that my read and write are automatically linked to one another. Here I can actually enable trending and enable alarming. Or if I use this, I can actually further fine-tune my parameter. But my parameter is perfectly fine. So let's just apply changes, save. And now you can see that my parameter has a position and it's displayed on the general page. So you don't have to use the display editor, but I think it's more easy than building this XML yourself. So let me publish this again and go to the DataMiner. Now you can see that I do see my page and my access key and secret key are on there. Okay, so next up, we can define our session. I already showed you this is what we need to build. And what we need to do is basically just make sure that all our parameters here are correctly linked to the ones that we created just now. So let me open Visual Studio again. Sessions are always added under the HTTP tag. So you can see for now, we don't have that tag available. That's a separate tag that is specific to HTTP. So that is not in your standard Visual Studio templates. So let's maybe add them here. But you can see that Visual Studio DIS also provides IntelliSense, so I can just add this tag quickly. And now to add my session, I have again a snippet available. So if I go to DIS, protocol, HTTP, you can see that there is a basic HTTP session snippet as well. Maybe something that you don't know or that not everyone knows. If I start creating my XML and I just type the name, hit tab and tab again, DIS will automatically, or the snippet will automatically be added, the default one. So that's a nice thing if you didn't know about that. That also works for parameters and all the other types. So I only have one session now, so I'll just use ID 1. The name is not mandatory, but it can be quite useful to have it, so I'll just call it ListMetrics. I will also only have one connection in here. I will only do one request, so I'll give it the ID 1. also call it ListMetrics. In our case, it's a post request. And the URL, the endpoint, we don't need to specify anything. And now here we can already link our status code and our content parameter. So here let's open these up. For my status code, I created a parameter with ID 14, and for my response, I created a parameter with ID 15. So let me configure those. And 15, and if I now hit enter, my snippet is complete and I have created my session. You can see here on the icon that it shows all parameters that are used for this session already. Now my session is not complete, I need to create my headers. So let's remove this one, we will not use it. And I will use another snippet to create all of them. So now you can see that I have all my headers. If I wouldn't have the snippet, I would have to, of course, do them one by one. And you can see some are static. For example, the algorithm will always stay the same, but the host depends on the region that you configured. The date is, of course, the date when you send your request. And the authorization header is a string we need to build, and we need to use our access key and secret key for that. Now our session is almost complete. The only thing left is, of course, add the body, and that is used or done with the data tag, and this also uses a parameter. In our case, we have the request data parameter here, which has ID 13. And now my session is complete. So now I have the request here, but I can't execute it yet. Remember, to execute, what do I need? A group. In our case, this will be a poll group. We will always use poll groups in this exercise because those are added to that queue, and a poll group is to just poll something from a device or send a request towards a service. In our case, our group will contain our session. So again, we'll use a snippet for our group, and then we can either include our session via DIS in the group, or in our group, we also have this icon here where we can add our session like that. So let's go to Visual Studio again. Go to my groups here. Note that with the default template, a group was already added. I'll come back to that one in a minute to explain why it's there. For now, let's use the group snippet. Let's give it an ID of 10 in this case, call it ListMetrics. And it's a poll group. Now to add my session, you can either use this icon, add existing session and select ListMetrics, or I can also go to my session here and include it in a group. Both do exactly the same thing, but it's just more convenient than typing it yourself. Okay, so now we have our group. What is the last thing we need to do, which is the most difficult part maybe, is we need to make sure that our headers are correctly set. And we also need to still execute that group. Remember, we will not use a timer, we will execute it once after startup. So for that, we will use a trigger and an action. Now to fill in the values for my headers, I will need a quick action and some C# code because I need to do some calculations and some encodings to actually build that key. I will use a snippet and I'll quickly run through it, but yeah, it's not the intention of this session that you understand exactly what you need to build that, it's just that you know how to do it. Okay, so let's go back to Visual Studio and maybe let's first create a trigger and the action we will use to execute our group. So let's use the trigger snippet. Also give it an ID of 10, and I will give it the name on startup execute ListMetrics. Why do I add the on startup here? Because then it's easy for me to know when this trigger will actually ever be used. And then all the other things here, I don't need to change them because my trigger will not have some kind of event. Instead, I will do this from our quick action. After we have created our headers, I will make sure this trigger is triggered and then the group can be executed. Okay, so let me remove these, we won't need them. The only thing we still need is an action to execute our group. So I can do that here, select this icon again, and instead of adding an existing action, I don't have any yet to do this, I will generate a new one. If I generate a new one, you can see DIS automatically adds the snippet here, and it will automatically be linked in my trigger. So my action, I'll also give it an ID of 10. You can give it any ID you want, of course, but it's always easy to have more or less the same IDs where you can, to be easy to find them back as well. So I call this execute ListMetrics. And now what do we need to do? We need to execute our group. So what do we need to put in there? The ID of our group, which is 10. Of course, it's a group, and we need to execute it. Like I mentioned before, if I show you, there are quite a lot of things you can do with an action. So if you need to know what all of these do, I suggest you have a look in the development library, and then you can know more about them. So now we already have our trigger and our action. So whenever this trigger is triggered, this action will be executed. And what will that action do? It will execute our group, which will send this session towards the service. So now we have this, we can actually move on and just make sure that we configure everything we need here, and then that's all we have to do. All we have to do is a bit easy to say. The first thing I'm going to do is actually open my precompile quick action that is used, or that contains the code I will reuse in other ones. So let me maybe also open the after startup quick action to quickly show you the difference. If you check here, it uses the option precompile and doesn't have a trigger. My after startup quick action, which is a normal one, just has a trigger parameter. So in this case, this quick action will run whenever parameter 2 changes. So let me first check quick action 2. When this quick action needs to run, it has a public quick action class in there, and it will start its code in the run method. So whatever you add here, that's what will be executed when your quick action is triggered. Now, if we have a look at our precompile quick action, there is no quick action class in there. It doesn't need to run anything. It can just have some namespaces with whatever you want to put in there, classes, structs, whatever you have there, methods, you can all put it there. For our exercise, we will need a bit of code. And as you can see, I added quite a bit. Why? Because we need to build our headers, and this also contains some other methods that we need to, for example, here, process the IP address that was set in our element. We'll come back to this when we need it, but for now we will work on quick action 2. So let me first explain how this one is actually triggered. I said we will do this after startup. So what do we do, or what do we have for that? We have an after startup trigger. You can see here the time after startup, and it's on protocol. So whenever our element starts, this event will trigger that trigger, and this one will execute this action. Now, what might not seem straightforward here is that we don't immediately run our quick action. Instead, we execute a group. What type of group? A poll action group. And in that group, we have an action which will then trigger the quick action. So this action will trigger a change on parameter 2. And parameter 2 is the one we have here on our quick action. Now, why do we use a trigger that first executes a group? That is because when this event comes in, that is as soon as our element starts. But that doesn't mean that everything has fully loaded yet. If we, for example, trigger our quick action right away, and we want to get our access key, for example, Could be that that value is not loaded from the database yet. That depends on another process, so it could be slower than actually starting our elements. If we first execute a group, what will happen is that group will be added to our internal queue, and that will only start working when everything else has been loaded in. Yeah, this might seem not that straightforward, but if you use the template, you never need to worry about it. You don't need to change that, you have it there for you. So our quick action 2 is what we will use to execute our, or to build the headers for our requests. So I'll maybe rename this to build ListMetrics request, so it's clear what this quick action actually does. And I am lucky, I have another snippet here to build our actual request. So what does this do? This will get, I don't know how well you know quick actions already, but I'll quickly go over the code and explain what it does. Firstly, we get all the parameter values that we need to build our request. So in this case, parameter 5 is our IP, and then 100 and 102 are the keys that we need. Then we just check if they are valid. Then here you can see I have some errors. Why is this? Because here I'm actually using a method from my pre-compile quick action. To use that, remember I need to import that in my other quick action. So here, I can easily do that by using this icon. Go to DLL imports. DIS will automatically show some assemblies that are frequently used, but it will also list my pre-compiled quick actions. So in this case, I'll just add this, and you can see it automatically adds the DLL import there. Okay. Now I still have this error. Why? Because those are in separate, if you check here, they are in separate namespaces, so I will need to add usings for that. And then for this one as well. So now you can see that my usings are here. I'm using namespaces from the other quick action, and I'm able to use all that code. So this is quite handy because later on we will create another quick action. If I would have this code, I would need to copy it multiple times, and if there's a mistake or I need to change something, I also need to do that multiple times. Okay, so let's move on with what we do. Here we just check if the IP we set on our element is valid. We create an object here. This is actually the request we need to send. So as I mentioned, we only need to send the namespace for this one, the date time that we need to send along. And here we have our method to create our authorization header. So, not going to go in too much detail what we do, but here you can see we actually need to do quite some steps to actually calculate that. If you're really interested in how it works, I suggest to have a look. But I'm not, I just want it to work. So I have my authorization header here. After that, I need to set all these parameters because they are needed for my request. And once they are set, you can see here, I have a special method called checkTrigger. And when I execute this trigger will be executed. And afterwards, I can then execute my group. So actually now I have everything that I need to send my request. So if I now upload my protocol, it will after startup trigger this quick action, fill in all the parameters, and execute my request. The only thing I will still do now for debugging is add my response status code and the content of my response on my general page, so I can easily know if my request worked. So let me publish that, and let's have a look on the DMA. Okay, it's working yet. Might have made a small mistake. Check back. So we have our after startup trigger, goes to action 1, executes the group, executes a poll action, use this quick action. And I already see what I missed. Remember I said my quick action always starts in my run method. I just added a method here to build my request, but I'm not doing anything with it. I still need to call that method, of course. So here I will call it. And now hopefully this does work. Check. DataMiner. And now you can see, as soon as my element restarted, it executed that request. Thank God it worked. And we can see the response here. So now you can see my response is actually a list of metrics. But for each instance ID, I get the name of a metric that I can pull for that instance. Okay. So my next slide here was that displaying that. I already did that. Now we have our response, but it's not that useful yet. We cannot really display it nicely. So next thing is creating our parameters to display that response. We don't want to just have that big string in there. What we want for our demo today is just have a table with an entry for each metric of an instance and a button that we can actually pull that metric. So what you can do is actually generate parameters with DIS. I'll show you how you can do that, but the annoying part about Amazon API is that it's not useful in this case because it's just a big list that we get back. But I'll show you how to do it if you ever want to. And then with the table editor, we create a table. We can actually edit our table, so that I'll show that as well. So let's go to Visual Studio again. In my case, I will add my params here at the back. So if I right click here, choose generate parameters. If you followed the previous session, Emily already showed how you can do it from a nib, but there are some other types available as well. You can do it from an XML, JSON, or even from a WSDL that you can load in, and that DIS will then parse and provide all params in there. In our case, we have a JSON response, so we could link it to a file or to text input. Let's just use that, and let me quickly copy that from here. So if I copy this and paste it in here, if I click next, DIS will parse this JSON and show you all parameters it would extract. Now in this case, this seems rather small for our response, but that is because it returns an array and it's every time the same object, of course. I will not use this because I want to quickly create a table. So to create a table quickly, I have a snippet. Well, creating a table goes that fast. So what is a table? It's a parameter of type array, and in that parameter you actually link you create a row here or an extra tag per column in your table. A column is actually just another parameter. Why is that? Because then we can give it a nice name, description, and we can add configurations like the type, but also units, decimals, or whatever you need for that column. If I use this icon here, I can open the table editor. That will open the same editor as clicking here. The difference is that if I click here and I would have 100 tables in my protocol, it will already pre-select the table for you. And then you can see there are two panes in here. The one at the top displays all columns in your table. And here you can define the type of column, if it's displayed, if you want to save it or not. And then the below part only displays the columns that are actually displayed, that you will see in Cube. And here you can define alarming trending, for example, and some other display options. So for example, the poll button, if I unselect that here, you can see it's removed here because it will not be displayed in my table. I will select it again because I want to have it, of course. So let's click apply. And now the next step is, of course, checking display editor and adding my table. Because I created the snippet, the page is already there. So you can see now I have another page here with my table on there. I can even access the display editor from here. So DIS is quite intuitive in using these different editors. I'll just cancel it because I haven't changed anything. Okay, so now we have our table. Let's publish our protocol again. If I check in Cube, I now have a separate page, but of course my table is still empty. I haven't configured in my protocol how I want my data to get in there. So to do that, we will need another quick action. This time it will trigger on our response parameter. So whenever our response changes, we want to trigger this quick action and then parse that response and update our table. To parse JSON, we use newtonsoft.jsondll. It's just a publicly available API that you can use to easily parse JSON. You can see we will create a separate quick action for that, but instead of checking here, let's just jump into Visual Studio. So if I want to create a new quick action, I can either do that here, or I can actually go to the parameter that I want to use as trigger. In this case, it's my response content. If I use this icon again, you can see I have the option generate new quick action. If I click it, it will automatically create a quick action with that parameter as trigger. I will give this quick action ID 10, and instead of calling it process ListMetrics response, instead I'll just call it process responses, because I don't want to create a separate quick action per response. Instead I'll have one and then just check which response came in and parse that there. Something extra that I need here now, of course, is again my precompile quick action, but also a reference to Newtonsoft DLL, because that's what I'll use to parse the JSON. So let's save that and open that quick action. And I am lucky again because I have another snippet. And this time it is the process ListMetrics response. So I will have some errors again because I need to add my usings. So first, this is part of the Newtonsoft DLL, so that I need using for. And then this means, or this call actually means I get the response string from my parameter, and I want to parse that or deserialize that into an object. The object is of type ListMetrics response, but I don't have a class for that yet, so here, let me add that here. Basically, why do I do it this way? If I parse it into this object, first of all, I know that the response I got back is in the format that I expect it to be. And now I have properties here that I can easily use. So here I also need a using, apparently, because I use link. And then here I have a using to my precompile quick action, because I haven't added it. Because I have some code in there to figure out what unit I need to show for that metric. You actually don't get the unit back, but this is hard coded, so I just have a list of all units available and I retrieve it for that metric. So what do? We pass our response into this object, and then we just loop over all metrics in there and add them to our table. So in the end, we don't add a row in our loop. Instead, we add all our rows to this list and update our table in one go. So with this fill array, this actually means that it will fill our table parameter with all the rows that we have in this collection. Now let's not make the same mistake as before and call this method. And now you'll see I have another error, and that is because here I don't expect an SL protocol object. The SL protocol object is basically the object you use to get all details from your protocol. I have used SL protocol extended. I used it here as an example because I don't know, even for more experienced developers, if they ever used it before. This is actually an extra, if I go to it, an extra class that inherits from SL protocol, but it adds a property for every parameter in your protocol. And then you can actually use that property to, in this case, read out parameters. In the background, it also just does a get parameter with the ID, but here this is more readable because you can actually see what you get. Just as an example, you don't need to use it, so let's just change it here. And now let's publish our protocol again. And let's hope that our table is filled in. Okay, so now you can see for every instance available in our Elastic Compute web service in Amazon, we have a couple of rows for that instance with all the metrics for that instance. Now if I click poll, nothing happens of course, because I'm not doing anything yet. And that's what we will do now. I tag this as an exercise for the people that want to follow along. If you don't want to or don't feel comfortable, you don't have to, of course. You'll still have to follow a bit what I do. But if you want to do that, you can. And actually, you can all start from the version that is on the red.skyline.be DMA. So we all have a version here, for example, for user 1. You can see that version is already updated a little bit to where I got. There is already parameters created for the status code and the response of our second response. And I also already added the quick action in there that you need to parse it. But we will need to add the group, the session, and then some triggers. I also created one for me, so I can show you how to start. So our exercise is maybe split in two. First thing is to execute the request, and then the second will be to handle the response. So let's go to Visual Studio. I will close this one because I won't use it anymore. If you want to import your protocol, you can make sure that you are connected to our DMA and logged in. And then with DIS, you can import your protocol. So in my case, I'm going to import, I need to think, 003. But in your case, you can import the one that starts with your user ID. The reason is that we don't start overwriting each other's versions. So if I import this, let's quickly check what has changed. I added these parameters for our GetMetricData request, and I added an extra quick action to build our request. And then I also added an extra method. Well, let me just open all quick actions. Yeah, first need to save. In my quick action 10, you can see I added an extra method to process the response as well. So let's start with the beginning and add our HTTP session. That's something we don't have yet. So all we have is our ListMetrics session. Instead of using a snippet, I'll just copy paste it and add it and change what I need to change. So we need to give it a unique ID. And we can change the name maybe to GetMetricData in this case. Next thing we need to change is here, instead of having ListMetrics for our target, we need to define GetMetricData. And we need to make sure that our parameters here for our request and our response are also updated. We use separate parameters. Why? Because in this case, if our response comes in, we can know what response actually entered. If we would use the same ID, there's no way for us in our quick action to know did we now get a ListMetrics response or a GetMetricData response. So that's something we will also change. So our data PID is 16, and then the others are 17 and 18. So if I save this and I check here, you can see that now I use the GetMetricData parameters and not the other ones anymore. For those that are following and can't follow with me, maybe some of my colleagues can help, or you can check on the full solution on the DMA. I'll hurry up a bit because otherwise we will lose time. But if you check here on the DataMiner, this example fully works. So if you need to know something and you haven't seen it from me, this one should actually work.
The element in the DMA is not active.
Which one is not active?
The one created on my user.
And what
I can't find
user?
the state. Does the service state of that?
Maybe Emily can check. So let me go back to Visual Studio in the meantime. So I have created my session, but now I need to add it to a group. In this case, I can only add it to an existing group, so I'll first need to create that. Again, I can use a snippet or I can copy it. So in this case, I'll use group 11, call it GetMetricData. And my session is now the second one. So it might be hard and not that easy to initially create your first request, but once that works, then you can easily add more to them. It's just a matter of doing the same thing again and maybe here and there do some tweaks. So now I have my group. I also need my trigger action for this one. So here I will also do some copy pasting. Data, and then my trigger also needs to be added. This is the same as you already saw me do before. The names of these items actually don't have to be unique, but I would advise you to give them useful names so it's easy for you to figure out what they do and you don't actually need to check the contents. So now what we have is our session, our group, and a trigger and an action. Now, if we click our poll button, we need to do something. In our case, again, trigger a quick action to make sure that we can build our request. That quick action is already there. It's this one, but I need to add my trigger still. So here I'll add the attribute triggers and fill in the poll ID, so it's 1006. Note this quick action is a little bit different than the other ones, and that is because we use the row equals true attribute. What this one does is basically make sure that this quick action can only be triggered by row changes in a table. Why do we need that? Because if you have a look at the contents of quick action 3, you can see that because it's triggered by a row change, we can get the key of the row that changed it. Now we have a metric here to build our request, and you can see why we need that key, because we need to get some values from that row. In our case, we need to know, of course, for what instance and what metric you actually want to retrieve. So once we have that, I'm not going to go into too much detail, we can build our requests. Now you can see that there's a little more JSON that we need to send. So here we built our JSON request, and you can see we provide the namespace, the metric name, and then also the instance we want to poll it for. You can see here that we also specify a start and end time because we need to provide the interval in which we want to get all values for that metric. And in this case, I also pass the unit. So let me publish that. Oh, I still forgot one thing. At the end of this method, I still need to execute my request, of course, and that's again with our trigger. So I'll use check trigger, and now it's the other trigger that I created. And if I publish this, I should be able to pull a value, but now it's this element. So now if I pull a value for this one, for example, I don't see anything here yet, but here I can see that I got a response back. I'm still not doing anything with that response, but we'll do that now. One side note, you have multiple instances here in this list. You will notice for some of them that you don't get any values. That is because not all of these instances are active at Amazon. You can only get metrics for an active VM or service. So if you want to get an active one, the one that ends with 77 is one that is active. So if you want to try it out, you can use that one. So now let's move along and actually parse our response. You actually don't need to do much for this one. Most is already done. The only thing you will have to do is go to our process responses quick action and add our new response parameter, which is 18 in our case. Now if you open up that quick action, you can see there's already a method there. So it gets the value, parses it, and then it will update our table and put the new value into that cell. The only thing we still need to do is call that method, and here you can see how I can know which parameter triggered the quick action. By executing the getTriggerParameter method, it will return the ID of the parameter that was the trigger for this quick action in this case. So I have my previous one in there, 15 was for my previous response. If I now add my other parameter, I need to, of course, execute the other methods. And now, as soon as my parameter 18 gets its value, this quick action will trigger. I will execute this, and this should update my cell. So let me publish that again. I now execute this request again. You can see that I actually got the value in there. Can anyone, or can you still follow with that? Maybe it's a bit much for a first protocol, but that's all we will actually do for the Amazon API for now. We could actually, of course, do a lot more, but that will take forever. We chose this API because it's useful for most of you, or at least you know their services. And yeah, in this exercise, you saw more or less everything you need for to create a protocol. So if you want to know more, you can take your time and go over the code. You can get the protocol locally and check it out. Last thing we will do is take a look at debugging. Emily already explained in the previous session that we have DIS inject, which is a step through debugging. I'll show you that in a minute. But let's first maybe check logging, because that can also be quite useful if you want to quickly check something. In this case, what I did in my process ListMetrics response method, add a log line to log my response. Where can I access that? If I am in DataMiner Cube, I go to System Center Logging. I can get the log file for every element. Or I can go to Skyline DataMiner Logging, and then there will be a TXT file for every element that you have on your DataMiner. So I can quickly maybe do that. I'll do it for the first one, which is called after startup. So there's a log snippet already. Let's put a method name in here. You can log whatever you want, obviously. Maybe I'll just response, and then here you can specify the type of logging. So if you have a try catch, for example, like you have here, and there's an error, you can log it as an error. Why do you do that? Because this will then also be picked up by other log files, and then it's easier to check if you have actually any errors anywhere in your element. So now let's just set it to this, and no logging. If I now publish my protocol, it has started, and I can go to System Center Logging, or I can right-click my element, select View Log, and it will open the log file for me. So now you can see there is quite a lot of logging added automatically by DataMiner already when your element starts up. If I go to the bottom, you can see I have an extra log line here that logs my entire response. So this can be quite useful to quickly check some things if you're not sure how something works. Or if you're even not sure that your quick action actually triggers correctly, just add a log line at the beginning and you will know for sure if it enters or not. The next thing that you can use that is available in Cube for debugging is the stream viewer. So this basically logs all communication towards the device and whatever comes back. So let me just show that right away. If I here right click my element, I can select View Stream Viewer, and then here all communication towards my device will be added. So if I just, for example, here execute a request, and maybe one that is active, and see my response. Now if I open the stream viewer, you can see that to this IP group 11 was executed actually 2 times. I got an OK back, and I can even see my response, or at least part of it. If it would be a very big response, it will not fully be logged here. But for that, you could use the sniffer. If you just want whatever is in here, you can save that to a file and check it later on. But if you, for example, want to know what is pulled within the next 5 minutes, then you can use the sniffer here as well. Just put an output location for the file it needs to save it to, and then set this to 5 minutes, for example, and as soon as you start, it will put all traffic that arrives or leaves our element into that file. Okay, and then the last thing is what Emily actually already showed this morning as well. If you want to go deeper into your quick action debugging, you can use this inject. Make sure that your Visual Studio runs as administrator. And in this case, it only works if we have a DataMiner locally on our PC. It also works remotely, but then I suggest you have a look at our help file. I cannot quickly show this because you will need to do quite a lot of steps to get that working. If you have it locally, it's quite easy. You just use this inject, select the element you want to actually step through, inject your quick action. So we added, for example, a breakpoint in quick action 10. I inject my quick action here, and here you can actually see DIS automatically also adds my pre-compiled quick action because we're also using code from that. And once I attach, DIS will do the necessary steps to make sure that you can actually step through and see the values for that, for example. I see it's 1:45. I don't have much time yet. Are there any other questions already that you have? Otherwise, I can maybe quickly show this on my local DMA. Check if I can quickly set it up. I should have some element running here. Let me connect to my own DMA. Let's hope that's the correct one. Okay, let's import that and open my quick actions. Save my protocol first. So my Visual Studio is running as administrator. I have quick action 10 here that parses the responses. So in this case, let me open this inject. So that's available through the tool windows here as well. But I already have it here. Let me maybe add it. So now I can select the elements. In this case, the Amazon CloudWatch, and I can inject my quick actions. I already did this once before, apparently. So here I just select the quick action I want to actually step through, add it, and then once it's added, I can attach to that. And now I am attached, so let me check my GetMetricData call. If I can add a breakpoint here. Alright. And now let's go to and let's pull something. Alright, so now I clicked the pull button, and as soon as I did that, my quick action entered, but it's waiting here because I have a breakpoint. So now you can see that I can step through, so my response is still null because this hasn't been executed. If I step to the next line, you can see now my response got its value, and I can step through like this and easily debug my quick action to see if there's anything wrong. For example, now I can also see whatever is in here, whatever results I got back. So that's quite easy to debug rather than adding log lines for everything you want to test.
But then you have to run this on the DMA.
Yeah. To do this easily, you would have to have it on the same server or computer that you're running it. There is an option to do it remote, but it requires a lot of tweaks. I even don't know them by heart, but it's available in the DIS help.